Hi. So in this video lecture, we are going to discuss about graphs in Python. So we are going to discuss how to draw different kind of graphs in Python, how to visualize different kind of data using Python graphics library. So we are going to work with this Matplotlib library. So this library has a package, a module for Python graphing. Matplotlib is basically the MATLAB library, but it also includes a module that is going to work for Python. So first we have to import here, import matplotlib. So inside matplotlib there is a module called pyplot. This pyplot, we are going to work with this pyplot. So we are going to import this module as PLT. So PLT is a short name for this module. So we are going to work with this module and we are going to use PLT name for it. And most of the functions, they are going to work for arrays in this PLT module. So we have to import numpy as well. So we are going to import numpy as np. So this PLT is a module that has many classes and many functions that are going to control different features of the graphs. So mainly there are two classes inside PLT. I'll just write here their names. So there are figure and axis. So we are going to construct objects of this figure class and object of this axis class, and we are going to work with those objects. The figure basically creates a figure, an empty template of figure, and axis has methods and which can be used to plot different graphs on that empty figure. So that we are going to discuss here in this class. But there's also a easy and short way to plot graphs in Python. So first I will discuss that, then so after that I'm going to discuss object-oriented approach to graphing in Python. So as I said, this PLT has many functions and also has two main classes, figure and axis. So you can also plot different kind of graphs without using figure and axis classes. You can simply use different various functions available in PLT to draw different kinds of graphs. So let's try to draw a graph of sine function. So for that we'll express all the data in array form, because most of the functions in PLT, they are going to work with arrays. So we define x using this line space function in the numpy class, np line space. So we are going to draw sine function from, let's say, from -5 to 5 with, for example, 20 entries or maybe 40 entries. So let's calculate sine function np dot sine on x. So we have these y values. Now we can use a function here that is available in this pyplot package, and that function name is plot. So you can simply use PLT because we are using this package, PLT dot plot. You see that there are many functions in PLT. So let me just show you all of everything that we have in PLT. So you see these are the functions available in PLT, and these C stands for classes. So we have classes, we have functions, and we have some attributes here, everything that we have in PLT. So we can use these functions and classes to draw different kinds of graphs. So for now we are only using some functions from PLT. So PLT, we can use this plot function. So you have to write x, then y. So this is simply going to plot a graph with x values given by this line and y values are given by sine function. So let's save it and run it. So you see that you get a graph of sine function. So there are two ways to view your graphs. Either you can view your graph in a separate window like this, or you can also view your graph here in the interactive window. So for that you have to use a command. So if you write %matplotlib, and here you specify that you want to view your graph inline. Inline means you want to view your graph here in this interactive window, inline. So after you run this command, every graph is going to show up here in this interactive window. So if you run this command now, if I rerun this code, I'm going to get graph here, but this graph is not interactive. You can't move this graph, or and you can't make changes to different features of this graph. So this is not possible if you are going to view your graph in this interactive window. But if you want to change this and would like to see your graph in a separate window, then for that you have to use matplotlib, and here you have to specify your preferred graphical user interface. So Qt5 is a name of the graphical user interface we have for Python. There are some other, if you know their names, you can write them here, but I'm using this Qt5. So if you run this now, all your graphs are going to appear in different window. Let's see this. So if you run this, you see that your graph is in now a different window. So here, this is an interactive window. You can control different features of a graph in this window. For example, if you go here, you can edit many things. For example, you can add title to this graph. You can make changes to x-axis. You can define the the minimum value, the maximum value. You can give title to x-axis. You can change scales, scale linear or logarithm scale. Similarly, you can make changes to y-axis. You can make changes to the curve. So there's so many things you can control from this interactive window, and you can zoom in different part of the graph. For example, you can zoom in this part of the graph. This is also possible. So there's so many things you can do with this graphic window. Okay, you can also draw multiple graphs in the same graph window. For example, let's keep x this array and define a new function. So I'm defining a function z, which is simply cos function. So cos of x. So now if you want to plot these two different graphs on the same window, you can simply write here. So x comma y is going to be your first plot, and then x comma z is going to be your second plot. But both of these graphs are going to appear on the same window. So let's save it and run it. So you see that we see two different graphs. One is the graph of sine function, and other is the graph of cos function. You can control many features of this graph. For example, you can suggest the title for y-axis, title for x-axis, and title for the graph, and also you can specify legends for different graphs. Let's see how we can do that. So this PLT plot has many optional arguments. You can check here using help function that what are the options you can pass to this plot function. So I'll simply use help, and here you can write plt.plot. So this is going to show you everything we want to know about this plot function. Okay, so if you look at here, it says that the plot function takes arguments, and what kind of argument this plot function takes, you can see this from here. It takes x, y, and then there's a format here. Format simply means that how you want your graph to look like. For example, you can have different marker of your graph, and you can have different line style, and you can have different sizes of the marker. You can specify the line width of your graph. So for example, here if you see that it says that plot x versus y, and the color of the graph has to be blue, and you have to use this O symbol to plot the graphs. That every ordered pair in the graph has to be represented by O. And if you look at this, it says that plot y, and then the color has to be red, and the marker of the graph is going to be plus sign. And here you can specify the line width. For example, there are many options. You can see the color of the graph is going to be green, and O is going to be the marker, and this is going to be the line style. How you want to connect different markers to construct a complete graph. And line width is that how thick or bold your graph should be, and the marker size, this is your marker, and here you can specify the marker size. So there's so many things you can do in this with this plot function. Let's try this here. So for this XY, we are going to have let's say the color we want is red, and we want to use this plus marker. And for this, we want color to be we want to use this marker O, and I want color to be green. So these all arguments are optional. You can use all of them, or you can skip any one of them. So let's run this, save this and run this, and you see that you get this graph. This XY is in red, the XY is in green, and XZ is in red. For XY we are using this plus. Okay, so XY is red, and we are using this plus marker. So we see this graph, and for this we use a green color, and we are using this O marker. You can also specify the line style, how you want to connect. So you see that now these markers are not connected. So you can decide how you want to connect, and there's so many options. You can check all these options here. So for color, we have these. We can use these characters, and similarly for marker, for line style, I mean, how you want to connect the markers. This is the style you can use. If you want to connect them with solid lines, you have to use this symbol. If you want to connect them with dashed lines, you have to use two hyphens. Similarly, dash dot line style. So there are different styles. Let's work with these two styles. So you're going to use the for the first graph this style, and for the second graph this style. Let's see how they work. You put style here. So color goes here, then marker, and then style. The marker colors you can change it, no problem if you use the different order. So green, marker, and here we are using the line style. We want line style to be the dashed line style. So let's save it and run it. If you run it, you see that the effect of these changes has taken place on this graph. So this is connected by style, and the green one is connected by the dashed lines. Okay, you can also add the titles to this graph. For example, you can also insert here. For example, you see that there's so many options here. Either you can insert title here with the keyword, or you can define title separately. Both options are available. So here, let's say, for example, here you see that it says that keyword argument. You can specify different arguments with keyword. For example, you can specify the title. So you can specify the title, and you can also specify the label of x-axis and y-axis, and label title of the graph. So let's do this here. So let's define a label for axis. So plt dot, here you have like label function. You can see label. So plt dot x label. You see that you have x y label, and you also have x label here. So x label, let's say the label is simply, I would just write x values, and you can also define y label, that is simply y values. So you can write anything you want here, and plt dot, you can also define title. So title is, let's say, this is my first graph, and you can also have legend. So plt dot legend, this function. So since there are two graphs, One is the graph of sine function and the other is the graph of cosine function. So first graph is the graph of sine function and the other graph is graph of cosine function. You have to specify two legends here, but you have to give that legends in the form of list. For example, for first function I want this legend sine, and for the second function I want this legend cos. So let's save it and run it and let's see how this works. So now this graph looks much better. So we have title for x-axis x value, title for y-axis y values, and title for the graph is this is my first graph, and we have used this legend here using this command. For red is the sine function and green is the cos function. Okay, now I want to show you how we can use object-oriented approach to draw the graphs in Python. Let's comment this here. So in order to use these two classes, figure and axis, we have to construct their objects, and there are a number of ways in Python you can construct object of different classes. So in this library there are some functions which are going to construct object of these two classes for us. So we are going to construct an object of figure class that is going to give you a template for figure, and we are going to use object of the axis class to draw figures on this empty figure. So how do we create object of these classes? For that we use a special function which is given in Matplotlib. So we define two objects. To the object of figure we give this name figure, and to the object of axis we give this name x, and we are going to create these two objects using a function which is given in this module plt, and that function name is subplots. So subplots function is going to create for us two objects. One object is going to have this data type figure, and the other object is going to belong to this axis. So as I said, there are a number of ways you can create objects of these two classes, but this is one of the most efficient way to create object of these two classes. So these subplots take number of arguments here, and they all are optional. So for now I'm just going to skip those arguments. We are going to work with those arguments later on. Okay, so this is going to create a figure object and an axis object. So we are going to use this axis object to draw things on this figure instance. So let's try that. Okay, let's use this approach to draw the same graphs that we drew before. So we are going to utilize the same functions that we used before. So let's remove these comments from here. In order to draw on this figure, we are going to use this axis methods. So axis object has a method plot. So let's plot this x comma y and x comma z. Save it, and then if you run it, so this is going to be comma here, you will get the same graph. Let's run this. So we see the same graph here. Now you can use this axis object to control all different graphs on this window and all different features of all different graphs on this window. So for example, you can set the title. So this axis object has a method by the name of set underscore title, which you can use to set the title. So let's say we set the title graph of sine and cosine. Similarly, you can use another method by the name of set x label. So this is going to set the label for x-axis. You see the difference here. When we are using these functions from these plot modules, so here we are not using any objects. We are simply using a function x label that is going to label the x-axis of this graph. But here this set title and the set label, they are methods for this axis class. So we are applying these methods on these objects. So there is a little difference between using functions from this library, or using object method of the objects from this library. So you can set the label here, let's say x values, and similarly you can set label for y-axis, set label y values, and you can set for example, you can set these values here, that how many values you want to print on y-axis and how many values you want to print on z-axis, and what are those values. They are called ticks. So axis dot set x ticks. So here you can pass any array. For example, if you want to set, for example, in this case we have defined that this x is an array which has 40 values between -5 to 5. So you can label just few values. For example, you can say that I just want these values on x-axis, -5, or let's make a difference of 2, -3 and 0 and 3 and 5. Let's say we want to show only these 5 values on x-axis. Similarly, you can set ticks for y-axis, and here you can show anything you want. For example, you may show from -1, the sine cosine function they can't go beyond -1 and 1, so you can start with -1 and 0, and let's say you want to show just 1. So the y-axis is going to have only these values. So let's save it and run it and see what changes are there. Let's save it and run it. So you see that we have this graph where we have title, graph, sine and cosine, and on y-axis we have only these three values, -1, 0 and 1. That is what we have specified here, and for x-axis we have these values.